Hey everyone, this is Nick VanAcker. I'm the Science on a Sphere coordinator for the MSU Museum, and I'm excited to bring you another Science on a Sphere virtual show. Today we're going to be talking about climate change. Should be a cool program. We're going to be talking all about some data sets related to climate change, what exactly climate change is, just kind of at a basic level, what humans can do to hopefully stop climate change, and then I also have a fun craft that we're going to be working on at the end. If this is your first Science on a Sphere virtual show that you're tuning in for, we do these every Wednesday at 3 p.m. So you can watch live, leave some questions down in the comments. I'm going to be down there answering any questions that you might have. Um, yeah, we can just get started. So the sphere itself is an exhibit that's at the museum. It was developed by NOAA, which is the National Oceanic and Atmospheric Administration. So they developed the sphere, but they also have developed a really fantastic app that we're actually able to use to do these virtual shows. And you can also download yourself if you want to follow along at home. So the app is called SOS Explorer, and it's available on any Apple or Android device. You should be able to download it from the App Store and then open it up and follow along with us. So I'm going to open up the app on my phone right now, just so you guys can kind of see what it looks like. I'll be pulling up all the data sets on this video, so if you're not able to download it, or if you'd rather just watch rather than interact, that's perfectly fine too. I'll be pulling up the data sets here. I'm going to be going over a couple of the buttons we might be using today. The first is going to be down on the right-hand side. This is the 2D, 3D button. And as you can see, there's a sphere in the middle of the screen here showing the Earth. And if I tap the 2D button, it just changes the way the sphere looks. So some of the data sets look better in 2D, some look better in 3D. So we might be switching back and forth between that just to check out different data sets in different ways. The other button is the overlays button, which is right next to it. And that pulls up this little window here where we're able to tap things like, for instance, country labels or country borders, and pull up just some extra information that might not be related to the data set, but might teach us some different things. So if you guys are interested in that, if you want to see how certain countries are related to different data sets, if you want to see, we can pull up grid lines, for instance, to see how areas of different latitude or longitude are related to each other in different data sets. This is just kind of a fun way to add some additional stuff to the data sets as we're looking at them. The first data set that I'm going to pull up is actually the one that's right in front of us, so we don't even have to touch anything to get there. And this is the Earth. So I'm a little biased because I live here, but the Earth is my favorite planet. It's the third rock from the sun, and as far as we know, it's the only planet in the entire universe that has life on it, which I think is pretty cool. I'm pretty excited about that, especially with Earth Day coming up. I'm just very Team Earth right now. And the Earth is really interesting. We might not think about it, we kind of take it for granted, but the Earth is full of all sorts of really complex systems that are able to work together that make us able to survive here. And it's kind of like the human body. So in the human body, we have things like the circulatory system, for instance, that pumps blood all around our body, but also pumps all sorts of nutrients and keeps us warm. We have things like the respiratory system, where we're able to bring oxygen into our bodies and let out carbon dioxide. And all those systems work together to keep us living, breathing humans. And the Earth has systems kind of like that too, where they all work together, that are able to pump nutrients around, that are able to keep the Earth warm, and that are able to keep the Earth as a living, breathing planet. And make us able to live here, which I'm very grateful for. So we're going to be looking at a couple of data sets that show some of those systems. We'll also be looking at ways that we can affect those systems. And then we will be just talking about how they all relate to each other. So I'm going to pull up a data set right now. It's going to be using the green button over on the left-hand side, the little glowing arrows. And as you can see, when I tap that button, this whole menu slides over. We've got the categories up on top. So for the first category, we're going to be looking at water. So if I tap where it said air right there, then I can scroll down to the water category and tap that. And then I'm going to be looking for a particular data set that is called ocean currents. So I'm going to scroll down here. There it is. It's called sea surface currents. So we'll tap the sea surface currents and temperature data set and be able to pull that up on our sphere. And so this data set is showing all the currents all over the surface of the ocean. Note that I said ocean and not oceans. It's because all of the oceans are basically one giant body of water. And we can see this really well, actually, when we're looking at some of the currents. You can notice that all of the currents don't seem to care where the Pacific ends and the Atlantic begins. Ocean currents are moving wherever the water wants to move. Um, you can notice that there's all sorts of different colors all over this data set, and that's related to the temperature of the ocean at that area. So there's a little menu down at the bottom that says sea surface temperature in degrees Celsius, and you can see that the more red an area is, the warmer it is, and then the more blue an area is, the cooler it is. So, looking at this, if you know much about the geography of the Earth, it probably makes sense to you. We're kind of rotating all around the equator of the Earth right now, and the equator is going to be the area of the Earth that constantly gets hit by sunlight. Obviously, not at night, but during the day, it's getting constantly hit by sunlight. It's getting warmer and warmer and warmer. So, it makes sense that area is going to be the most red. And if we go up to the top of the world, for instance, we can see that that area has got some blue currents in there. Same thing down at the bottom, down by Antarctica. It's got lots of blue currents all around there. And that makes sense. That area is getting hit by the least amount of sun, so it's probably going to be part of the coolest area of Earth. You might notice, though, if you're looking at some of these currents, that they don't always follow that pattern. So, for instance, we can look at one that's right here. You can see that, of course, in the equator area, it's very red, orange, seems nice and warm. But there's this one current that follows up along the coast of South America, all up along Mexico, past Florida, and it seems to be a lot warmer than it has any right to be, and continues to bring that warmth all the way up across the Atlantic Ocean into areas like Spain and Great Britain, which are pretty far apart or pretty far away from the equator. Um, and this is showing one of the cool things that one of Earth's system does that kind of acts like the circulatory system, where these currents are able to bring warm temperatures from these warm areas like the equator up to areas that should be cooler, and bring warm temperatures, bring warm weather, and also bring all sorts of nutrients and life, which is pretty interesting. There's another one down off the coast of South America on the other side here, if it'll let me take it. You can see that there's a current going all along the western coast of South America and going up to an area right in here. This is actually where the Galapagos Islands are. And so these currents bring nutrients up from Antarctica all the way up to the Galapagos Islands and keeps it kind of cooler than it should be, or what we think it might be. But it also brings all sorts of things like fish and krill that end up feeding a lot of the life on the Galapagos Islands, which is pretty cool. So you can see that these sea surface currents kind of act like the circulatory system for the Earth. They're really big, they're really complex, but they're able to move nutrients and energy all over the Earth. I'm going to pull up another system that occurs on the Earth, and this one actually isn't a natural system. This one is a man-made system. So I'm going to go to the people category to see man-made system, and then we're going to be pulling up the one that says human transportation, which is right here. And so when we pull that one up, you guys can see that this system is pretty complex. It looks kind of similar to the ocean currents. Obviously, it's straight lines instead of those little curly cues, but you can see that it's all of these colored lines that are connecting the entire Earth. And this system works kind of similarly to the ocean currents. All these human transportation systems are moving things around the Earth. It's not temperature necessarily, but it could be nutrients, it could be energy, it could be all sorts of different stuff. So these lines that are different colors represent different types of transportation. And this is where it gets kind of crazy with this data set. So when we're looking at all these blue lines, they represent the shipping routes all over the Earth. So those ships could be bringing packages that are being mailed all over. It could be bringing nutrients, could be bringing plastics that are going to be recycled, all sorts of different stuff. But these blue lines only represent 10% of the shipping routes over the entire Earth. So imagine if this is only 10%, we actually have 10 times this amount of blue lines covering the entire Earth, covering all the oceans as ships move back and forth constantly across the Earth. The red lines represent plane routes. You might be thinking, oh, this is plane routes over the course of a year. That makes sense. These red lines actually are representing the plane routes that occur over the course of one day. So if you can imagine, it's this times 365 to get the plane routes for a year. There are constantly planes moving all over the Earth all of the time. And there's actually another color on here that I didn't notice the first time I saw this data set, and that's the green. And the green actually represents all the roads all over the Earth. And of course, on those roads are going to be cars and buses and motorcycles and all sorts of different things that are ferrying people and food and packages and everything all around the Earth. And so you can see this is a really interesting data set. It's basically as complex as the ocean currents data set, but it is run by something different. So the ocean currents data set was run by the sun. We could see that the sun was hitting the equator, pumping these nutrients and all this temperature around the Earth. The human transportation system, some of it's run by the sun. We'll talk about solar power and other alternative energies in a little bit during the program. But most of it is run by fossil fuels. Fossil fuels, if you aren't familiar, are basically things that are dug out of the earth and burned to power systems like this. Things like coal, gas, oil, anything that we can burn that is able to power these systems. The problem with that, of course, is that when we power these systems with fossil fuels, it ends up releasing carbon dioxide into the atmosphere. And I'm going to pull up another data set so we can kind of see the results of what this human transportation data set does. So we can go to category, and then we can pull up the air data set. And then we'll go up to the top here and pull up one that says carbon dioxide concentration. And so when we look at this data set, you're going to be able to see a lot of these different colors here. You can see there's areas that are red, blue, green. There's a little key down at the bottom that says CO2 mixing ratio, parts per million. And parts per million basically just means how many, if you had 1 million particles, how many of those particles are CO2. So we can open this up a little bit. We can expand it a little bit to make it a little bit larger. And you can see that it says at its highest, which is going to be kind of a pink area, it's 395 parts per million of CO2, which doesn't seem like that much, right? It doesn't seem like it would be that big of an issue. But it is. Slowly over time, as we're adding more and more CO2 to the atmosphere, it's causing global temperatures to steadily rise over time. It's not going to be a huge rise. We're not going to notice one day, oh, it's 80 degrees warmer than it was yesterday. Usually, sometimes that does happen, but it's not something that we can necessarily feel as humans. We won't say, oh, it rose 2 degrees today over the course of the entire Earth. But it causes problems with the Earth's systems. So, for instance, if we were to look at the water data set again, we can pull that one up. Go to our water data set and sea surface currents. As the Earth gets gradually warmer, it could mess with these ocean currents. So the whole reason the ocean currents work is because of differences in temperature. The sun's hitting the equator at these areas, and the warm water wants to get to an area that's cooler, just because of the way that temperature works. Temperature wants to be as constant as it can over an area. So the warm water is trying to get to a cooler area, but if all the areas of the Earth are warm, there's nowhere for that water to go, which effectively slows down or at least changes the places that currents are going. So if we look at an area like the Galapagos again, if these currents aren't moving these nutrients around, maybe the Galapagos wouldn't have so much cool stuff going on because those currents aren't able to get nutrients to that area. Some species might die out. And that happens all over the Earth and is currently happening all over the Earth right now. That as areas get warmer, things are dying, things aren't able to survive, and that those slightly warmer temperatures, there's more extreme storms, there's more extremes in weather, and it doesn't just mean warmer weather either. Some of these, the temperatures are slowly raising over time, but it can cause more extreme winters and honestly just more uncertainty related to weather and climate and how things are going to go, more uncertainty and more severity. So that's why you're going to have things like flooding, you're going to have things like droughts, you're going to have all sorts of different stuff going on because these temperatures are slowly warming and changing these really kind of delicate systems. I'm going to go back to the human data set that we were looking at for a second as well. So we can go back to people and then go to human transportation. we talked about, this data set is really complex. It's looking at all sorts of different systems all over the earth, all powered by fossil fuels. So you might hear these things and they sound pretty scary, because they are pretty scary. And you might think, well, why can't we just stop burning fossil fuels? Wouldn't that be a fantastic solution? Just flip the switch, stop burning fossil fuels, stops releasing carbon dioxide into the atmosphere. We don't have to deal with this anymore, which would be fantastic. But these systems are so complex and so huge and connect everything on Earth right now. And it's something that we're hearing a lot about nowadays, how all these global systems are connected. Um, it's impossible to just turn them off overnight. It's impossible to just stop them all from going. We're doing a pretty good job of it right now, but it's still, in order for humanity to be able to survive, we need these systems to stay in place until we develop other systems, at least. So the solution can't be to just stop using fossil fuels. There has to be something to fill those gaps. And luckily, people are working on that. There's lots of different things that people are working on to try and fill in that energy void if we were to stop using fossil fuels. But there's no magic bullet. There's no one way to fix it. So I'm going to be pulling up a data set right here. If we go into the air category, we should be able to pull one up that's related to wind. I'll be able to find it here. All right, so we're able to pull one up that's related to wind, and this one's just called winds. And so this one is going to be showing the wind all over the Earth, which is pretty cool. You can see that there's all of these different winds moving things around the Earth. And these are winds that are higher up in the atmosphere. And you're able to see that these are related to temperature too, the same way that the ocean currents are related to temperature. There's areas that are warmer and areas that are colder, and wind is basically the same as ocean currents, just in the atmosphere. It's warm air trying to move to an area that's cooler, or cool air trying to move to an area that's warmer, just trying to even temperature out over the course of the entire Earth. I'm actually going to pull up this wind streamers one as well that's right above it, because it shows a little bit better that a lot of the wind that occurs on Earth is happening all over the place, but one of the best places for wind, some of the windiest places on Earth, are along the coasts. So a lot of people are trying to set up wind farms along the coasts, for instance. I know here in Michigan, there's a lot of wind farms up near the Saginaw Bay City area, which is, kind of near the coast of Lake Huron. But so the coasts are really good areas for wind power. But unfortunately, wind power isn't a perfect solution. For one, in order to get wind power, you need to have turbines that are able to collect all of that wind energy. Turbines are big, they're expensive, and they don't always work all of the time. If there's no wind blowing, they're not able to get that wind energy. So wind energy is a possible solution, but it's not the only solution. It's not the best solution. It's just a solution. There's another solution as well that I think I mentioned earlier, and that you guys are probably familiar with as well. If we go to the space category, we're able to pull up the image of the sun. The sun X-ray 2003 is one of my favorites. I just like the way that it looks. But solar power is another really fantastic way that we could get more energy for our global systems. A lot of people have solar panels on their homes. There's talks about using solar panels for cars, for all sorts of different stuff. MSU, Michigan State University, where the museum is part of, is building a whole huge solar field in the south of campus, which is going to produce a lot of energy for campus, which is really awesome. But again, solar power isn't the magic bullet. It's not the one solution to stop climate change. It's a really cool solution if we're able to use all sorts of solar power to power all of our systems. It'd be fantastic. There's actually a cool statistic. If we were to cover the entire Earth in solar panels, we could get all of the energy we needed for an entire year of power for the Earth in just one day, which is really cool. The idea that we might be able to get all of that energy from the sun, but of course, that's not practical. Solar panels cost a lot of money. They're getting cheaper, but they still cost a lot of money. You also need to have them in just the right place for the sun to be able to hit them in order to be able to get that energy. So there's no one solution to stop climate change. It's going to be a combination of solutions. It's going to be using the power from the sun. It's going to be using the power of wind. It's going to be using the power from waves, from geothermal energy, maybe from nuclear energy, maybe from systems we haven't even thought of yet. And it's not just going to be one group of people either. I've been saying, solar panels are expensive, wind turbines are expensive. They're expensive for individuals, but they're not as expensive for governments or for companies. It's going to be people all coming together, from individuals to governments to organizations, everyone coming together to stop climate change. It's got to be a global effort, or else we're not going to be able to do it. So it's really fantastic if you're able to do things as an individual. A lot of people will think, well, what can I do as a person to try and stop climate change? One of the main things that you can do is just try to be aware of it and try to support other people who are also trying to stop climate change. You can, of course, walk or ride a bike or use public transit instead of driving a car. You can recycle things, or you can reuse things. One of the big things is, rather than buying products, trying to reuse stuff that you already have, which is really fantastic because it stops stuff from being produced in the first place and using all of those resources to ship things around the world. If you don't need a thing, you already have a thing. That's a really fantastic way. But also just supporting companies and governments and individuals who are supporting the earth, who are trying really hard to stop climate change. Your voice is one of the most powerful things that you have. So that's our climate change program. It's really fantastic. There's going to be a lot of other resources related to climate change on April 22nd for Earth Day, so be sure to keep an eye out for that from all sorts of different sources. But for now, we can go to the craft. So we have kind of a fun craft today. You guys might have seen this before, but it is building an eco bottle. All right, so now it's time for the craft portion of the program. So today we're going to be making our own little microclimate inside of an ecosystem bottle. So I have an example of the one that I created right here. You can see it's got a plant, some dirt, and so we're creating our own little microclimate inside of this bottle. It's a pretty simple craft. All that you're going to need is some sort of clear container. I used a 2-liter pop bottle, but it could be anything like a glass bottle, a jar, any sort of clear container. You're also going to need some small rocks or pebbles, some dirt, some plants. This could be something like a moss, or it could be leafy plants, maybe a flowering plant, a weed you find in your backyard. Anything will work. You're going to need some water, and then also some leaves, sticks, rocks, or other decorations. It's a really simple process to put this bottle together. It's just a couple of steps. So the first thing that you're going to do is to fill the bottom of your container with the small pebbles. I filled them up just above these ridges here, so it's about maybe an inch of pebbles. And basically all you want to do is just create a thin layer down at the bottom, and that's going to help retain water. After you add the pebbles, you're going to add a thick layer of dirt on top of it. I usually will add about 2 times the amount of dirt that I added of pebbles. So I got just a couple of inches of dirt down at the bottom here. After you add the dirt, you're going to add your plants. And again, the plants don't really matter. You can add all sorts of different types of plants. The main thing is just you want to make sure your plant will fit through the hole in the top. You can see this big leafy plant in here. When I dug it out of the ground, I was able to kind of fold up the leaves and put it through the top. So that was no big deal. And then once the plant is in your bottle, then you're going to be able to position it and plant it in the dirt. It can be a little bit tricky if you're using a bottle like this, so I recommend using something like a skewer or a dowel, or maybe a knitting needle or a chopstick, or anything small and thin that you can kind of put through the top of the bottle and then use it to position and plant your plant in the dirt. Make sure its roots are all nice and covered. I have a couple of different plants in here. I have one that looks like maybe some sort of wild geranium, and then a couple of tree seedlings that I was just able to find in my backyard. Some of the plants you put in here are going to survive, some of them aren't. That's just kind of the way that this works. You're creating your own microclimate that's different than the climate outdoors. So some of them might like it a lot, some of them might not. If you use a plant like moss that likes high humidity, that's going to survive a lot better in here than some leafy plants. But some of the leafy plants, you like high humidity, so it just kind of depends. After you plant your plants, then you're going to add your sticks or your leaves or other decor. You're going to do that the same way by putting them through the top of the bottle and then just kind of moving them around with your chopstick or your dowel and arranging them however you want. And then after you do that, then all you have to do is just add a little bit of water. My dirt was already pretty moist because I gathered it when it was raining outside, so I didn't have to add very much water to mine. You're just going to want a little layer of water down in the bottom, and then you can add more if you need to, or you can remove some later if you need to as well. So it's not necessarily a closed system. You can take things out and put things in. But after you add the water, you're going to put your lid on, and you want to put your lid on just loosely. You don't want to tighten it all the way down. The idea of this is to create a closed system as much as you can, but you still want some exchange of the air outside and inside the bottle. But so once you close it a little bit loosely, then you're going to put your bottle up in a sunny window and let it sit. So this is some pictures of me constructing my bottle. It only took me about 15 minutes this morning, so it's a pretty quick craft. You can take as long as you'd like on it, but again, I just gathered all the stuff out from my backyard, so you don't need a lot of crazy materials. The really fun part about this, though, is that now you've created your eco bottle, you've created kind of a microclimate. Now you have the chance to experiment. So there's lots of different ways that you can experiment with this to try and see how this bottle could replicate how climates change. So for instance, you could maybe leave the top of the bottle completely open, or you could fully close it. You'd want to think about what things might happen if you were to leave the bottle fully open or fully closed. Maybe write them down ahead of time and then make observations. What happens if you leave it closed for a day? For a week? What happens if you leave it open for a day? For a week? Does it get drier? Does it get wetter? Can you feel the bottle being too warm or too cold? All sorts of different stuff. You could also move where you're putting your bottle. Maybe you put it in a really sunny spot. Maybe you put it in the shade. You could put it in a warm spot, in a cold spot. Again, make some ideas. Write down some ideas of what you think might happen to the bottle, and then make observations and see what you think what actually does happen. You could also add different critters to your bottle. So for instance, my bottle has springtails in it, which are little invertebrates that eat mold and all sorts of different kind of decaying stuff. You could also add worms or roly-polies or any other sort of critters that you might find in the garden into your little bottle and see how they affect your system as well. If it's something that eats plants, your plants might disappear. If it's something that eats dirt, you might notice a really good improvement to your bottle. So there's all sorts of different cool stuff that you can do to kind of experiment with different ways that a climate could change inside this tiny bottle. If you're up for a real challenge, like I said, this project was pretty quick. It only took about 15 minutes, but you can create something that takes a little bit more time, probably around an hour, and that's called an eco column. So the instructions are down there on instructables.com. You can see there's lots of different areas of this eco column that more accurately recreate the Earth's climate. So there's a terrestrial chamber up on top, and that's pretty similar to the bottle that we've created right here. It's got plants, it's got dirt, it's got rocks. But below that bottle, there's another bottle. That's a decomposition chamber. So that's going to be areas where your leaves and your sticks and your grass would be decomposing and breaking down into simpler nutrients that would be able to be used by the plants. And then down at the bottom layer is the aquatic chamber, and that recreates things like lakes and rivers and oceans as they exist on the Earth. So it creates this really, really cool cycle that you're able to watch inside the eco column. Like I said, it does take a little bit more materials, it takes a little bit longer, it might be a little bit more challenging for some of the younger viewers, but it is a really, really cool project if you're able to get it to work. So yeah, that's the end of the program for today. If you guys do make these eco bottles, feel free to share them on our social media. You can take pictures of them and share them on our Instagram or our Facebook or our Twitter. I'm really excited to see what everybody ends up creating. All right, thank you so much for tuning in, and I hope you have a good rest of your day.